All right, let's talk about continuous random variable, the probability density function, part 2.
12:30 finish, that's so good.
So what I've done yesterday is I have shown you
11 finish.
triangular distribution, which is a non-uniform, and I show you a rectangular distribution, which is uniform distribution. So we are going into something different now. So this time, the probability density function could be exponential, could be sine, could be cos, could be anything.
Damn.
Alright?
You're gonna have to do.
So you need to
Integration.
know what is a non-uniform probability distribution function and be able to use calculus techniques to determine the PDF. Alright, then calculate simple, compound, and conditional probabilities. Those are important. So the journey so far, we did look at uniform, continuous uniform distribution, which is rectangular, and non-uniform, which is triangular. Alright? So far, due to the nature of these shapes, we could use the area formula to determine the probabilities. So there are other non-uniform distributions. Your knowledge of calculus will be very, very useful. You need to know your calculus. So everything is linked together in this course, which in my opinion is really good. So now, if you are asked to check if the PDF is valid, you must always take the two tests. One test is fx has to be greater than equals to 0 within that domain, and also the area under the curve must be 1. So I stated here minus infinity to positive infinity. So when you are doing this, you are actually looking at the lower bound and the upper bound, that's all. A and B, that's it. Alright? So here, note in this situation, minus infinity is the lower bound, and which is A, and infinity is the upper bound, which is B. Alright? So you may have situation where the distribution may look like this. That, and then curve up, down, straight down, and there. So your negative infinity will be from here, if this is the point. Depends on what the domain is, A and B. Alright? The area under the curve has to be 1, and also the probability of fx has to be greater than 0. Both conditions must be stated. Alright, let's have a look at example 1. So let's have a look at this graph here. The graph shows a probability density function y equals to fx for a continuous random variable. Use calculus technique to determine the value of k. So how do you use calculus technique?
K just 1.
Alright. Now the first thing you need to do is think about the domain 0 to 1. Alright? How do you work out the equation here? And then how do you work out the equation there?
So it's x.
So you know fx is equal to x, and between 1 and 2, fx is minus x plus c. Alright? You can work out the gradient. Gradient 1 and 1, so gradient is 1, gradient is minus 1. You need to work out c. If I substitute 1 and 1 in there, c equals to 2. Alright? I skip a couple of steps. So once you've done that, here I ask you to use calculus technique. Read the question carefully. You cannot use the area formula. Alright? You can only use the area formula if they did not ask you to use calculus technique. So I've written down fx, what it is. So for the probability density function, fx equals to x between 0 and 1, and then minus x plus 2 between 1 and 2, and then 0 everywhere else. I mean, this is optional. I write it to make sure that I know what it is. When I do the integration, I can straight away do that. So I know that this is greater than k, so the area that I'm looking at is here. Correct? I'm not looking at anyone else, it's just here. So I'm going to integrate from k to 2. So all I need is this this equation there for that line, for that function. So integrate that, and from k to 2, right? K to 2, you must write down your integration and write this one out. And then that equals to the area, which is 0.02. Alright? And you can sort out what k is. Alright? K, use your calculator to solve it, is 1.8 or 2.2. But you cannot accept 2.2 because anywhere else is 0. Therefore, k is just 1.8. Right. Make sure that you state the reason why you reject. K equals to 2.2. That's important.
Because it's not in the.
So using calculus technique, if the question did not ask you to use
0.02
calculus
there.
technique, you could just use the area formula. Alright?
Yeah, it's
Area
just
formula. I mean, in this sort of situation, perhaps calculus technique is slightly more straightforward. Although you know that the area is 2 minus k times that height times half equals to 0.02. You will work, it will be the same. Alright? So calculus technique, this is how you do it. Now, let's have a look at example 2. For each of the following functions, determine with reasons whether or not it could be a probability density function for a continuous random variable over the specified interval. Alright? Now, here, just a quick convention. If you've got a square bracket 1 and 3,
Means 1, 2.
that means x is between 1 and 3 inclusive.
There's no
Alright.
first one.
A round bracket 1 and 3 means x is greater than 1 and less than 3. Does not include 1 and 3. So that's just a convention. Square bracket means it includes that. So now recall what I say to you. Two conditions. Fx has to be greater than or equal to 0 for all for in the domain of 1 and 3. So if you look at that,
It is.
all the values in 1 and 3, this number will be positive. So that's the first condition, state that. So condition number 1, fx is 0 for the interval 1 and 3, between 1 and 3. Always state that because it has, once you state that, both conditions must be satisfied, so therefore if one condition is satisfied but the other one is not, it is not a PDF. Alright? So, and then do your integration. You need to evaluate your integral to make sure that it is 1. If it is not 1, then it's not a PDF. The area under the curve must be 1. So I'm going to show you the first one, and then I'm going to give you a couple of minutes to try out the second one. Alright? So here, you know that it's 18. So since the area under the graph is not 1, it is not a PDF. It cannot be a PDF of the CRV. Alright, try number 2, please. Start off with the first condition and then do the integration for the second one. Excellent. Grab your pen out and do something. You need to do your integration. Remember, your integration makes life easy for yourself. Take the 3 over 32 out from the integration. Just integrate 4 minus x squared. Alright? So two conditions must be satisfied. The thing is, a lot of people will forget about the first statement. Most people will just start doing the question and try to integrate and find the area. So that statement is important. You don't even have to do any calculation, just looking at it, you know that it is greater than 1 gram. Just need to be able to do your integration for this one. Your definite integral. Write it out. I would say that example 2b part B, it's potentially whatever, it's potentially a calc-free question, and it encompasses the knowledge of PDF or CRV as well as integration. All right, definite integral. Now, do you all agree to my answer? Area is 1. So probably this question, if this is in a test itself, to me is worth 4 marks. This is 1 mark, state the condition, and then the integral, definite integral is 1 mark. Evaluating is another mark, and then the conclusion is another mark, 4 marks. So 1, 2, 3, and 4. That's how I would allocate marks. Some teacher may just say 1, 2, and 3. So it depends. Okay? Happy with that?
Yeah.
We'll move on to the next bit. So example 3 now. Given the diagram to the right, shows a probability density function. Determine the value of k. All right, you have already been told that this is a probability density function, and you know that this area here, all right, between 1 and 3. See, the dotted line is not included. It's only the solid line. So 1 and 3 there, that area in there would be 1. Correct? So you don't have to test for the validity of the PDF, but you need to know that the area, that area there is 1. Let me highlight that. This area here is 1. Now again, this is a geometrical shape. It depends on whether you want to use area or calculus. I did not specify that. So I could use calculus, which is that bit here, because I know integrating from 1 to k, the area under the graph is 0.75, and therefore this is what I get, and I can solve it now. So k squared is plus or minus 7, remember, you need to reject k equals to square root of minus 7. Minus square root of 7 because the domain is between 1 and 3. Alright? Alternate. I'm showing you the alternate method, not using the calculus, using area. So using area, you know A is 1 and 1 over 4. Alright? B is k and k over 4. So you know that 2 point there. And you can work out the height here and that length there. So the length there is k minus 1. This is k over 4. This is 1 over 4. So using area. Area is 0.75. Now, because I'm using 1 over 4, so I've changed the area to 3 over 4. Makes life a little bit easier for yourself, where you've got the same denominator. And working that out, you still have the same value. Alright? So that dot 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 means just follow through. Alright? It's up to you whether you want to use area or whether you want to use calculus if the question did not specify.
Yeah.
Alright? So I've shown you both way of doing it. Doesn't really matter whatever way you think you like to do it. Now the next bit, example 4, given that each of the following shows a probability density function, use calculus to determine the value of k. Alright? In each case, determine the value of m such that its probability of x less than n equals to 0.5. Here, you need to think about the area. So between 0 and 2, the area would be 1. So y equals to kx squared, you need to integrate that between 0 and 2. Minus negative infinity is 0, plus infinity is 2. So 0 and 2, the definite integral. Area is 1. Alright? Once you recognize that, write that down straight away. You should be able to do a question like this. You should know how to integrate that. And therefore, k is 3 over 8. Alright? Pretty straightforward. Know your definite integral, and you can work out what k is. And you know the area is 1. Now the next step. Probability of x less than m equals to 0.5. Alright. So you know that it's somewhere the area here. M would be here. So area here is 0.5. Now just remember one thing. 0.5 in this case is the median, not the expected value. 50%, because it's a non-uniform and it's not a symmetrical triangle. Yeah. So unless you've got something like this, which is symmetrical, then that is your median, that is your mean, and that's your mode. All right. But it is not. So here you need to think about how to work out the area. Area under the curve is 0.5, and you are integrating from 0 to n. Okay. Less than is from here to here. Greater than is from here to here. All right, so it's less than. I mean, really, if you want to integrate from m to 2, 0.5, that is that's still correct because it's the median anyway. Right, both areas is half. But since I specifically say that it's s less than 5, so integrate from 0 to m. And then you can work out m is to cube root of 4. Now, without calculator, leave it as a cube root of 4. With calculator, possibly give it as 2 decimal places and specify as 2 decimal places. Alright? Now, I'll give you 3 minutes to try second question. Now, remember something like this. Alright? Fx is sine x. What does the graph of sine x looks like? Okay?
Starts from
It
origin.
goes,
Goes up and down.
and down and up. Alright? Now, here, it says that sine x between 0 and k. You know that the area, it could expand all the way, but it will not go into the negative value. Correct? Because fx has to be greater than 1
Yes, it has to be within that.
for probability density function to be valid. So therefore, you are actually looking at somewhere around here. That bit, that's all. That bit of the curve. 0 to that bit of the curve. The next bit when it touches 0. It will not go over there, it will not go under. Alright? It cannot go negative. So you are only looking at this bit of the sine curve. Because it's specified that it's from 0 onwards. Alright? Yeah? If it is specified it's from pi onwards, it's from here going to there. Again, it's only positive. So anything between that and that, it cannot be a positive, it cannot be a probability density function. So again, use your integration.
Yeah.
Sine of dx over x is 1, and you therefore, you could work out
That's pi over 2.
k equals to pi over 2. Alright? And then use your integration 0 to n to find the value of n. Okay? So remember, look at what the lower bound is. I mean, cos k equals to 0, that's lots of solution. But it has to be from 0 to k. It has to be the first bit, that's all, between here and here. Yeah? Understand it? Got it? It's from 0 to pi. That's all. It cannot be anything else. Anything under there? Nah. Under there, no, that's negative. Alright? Cos k has a lot of, it can be lots of value, but in this case, you can't. It's only between this bit here, because it starts from 0. So therefore, you can write this one up and work out n equals to pi over 3. Alright?
Yeah.
Happy with it? Understand how I've started doing it? Understand why I cannot have more numbers? It's only 1, because it's only the first bit, starting from 0 to k. Has to be positive.
Yeah.
Alright? Now, non-uniform distribution involving exponential function. So an exponential function of the following form can also be a probability density function. Alright? Since we do not have an upper bound in the domain, so in terms of exponential function, there's no upper bound. So for this to be a PDF, we actually integrate between 0 and infinity and make sure that the area is 1. Alright? Okay. Infinity is not a value and hence cannot be used to calculate a definite integral using the calculus method. So any problem involve integral, in this case, you've got to use your class pad. Alright? Just remember this, when you are integrating from 0 to infinity, use your class pad. Now let's try this. Alright, example 6. You need to show your class, use your class pad. Anyone without a class pad today? Use your class pad. Try the integral, please.
Amazing.
Thanks, mate.
Right.
Bro, what?
Good.
Did you all get the same thing as me? Did you use your class pad? Did you get the area under the graph to be 1?
Yeah.
Good. Alright, so we can then look at probability of x is greater than 2. Now, probability of x is greater than 2, which means you can either integrate from 2 to infinity, or 1 take away this bit, less than 2. Alright? Now, the thing is, if you do not have a calculator, you probably have to do it that way. If it is a non-calc, if it is calc-free section. Alright? Calc-free section, it will tell you exactly what is correct. This is a PDF. And then, if you can't evaluate from 2 to infinity, so therefore you have to evaluate from 1 to 2, and then 0 to 2, and then 1 minus that. Alright? Yeah? Happy with that? So if you've got a calculator, you can integrate from 2 to infinity. See, there are 2 ways of answering this sort of question. So therefore, you can work out that to be 1 over e. Of course, if you have a calculator, straight away, you will be able to get 0.3679. Alright? Now, the next bit, see, generally, in this sort of situation, what you would do is try to actually draw it on the graph, sketch it. So let me sketch this for you. So probability of x less than 3. So this is the bit that I'm looking at, less than 3. Alright? This bit here. And then probability between all 2 and 4. 2 and 4 is here. Alright? Now, what happened is, this is actually asking you to do P, A, union B. Right?
Yeah.
So therefore,
0
it's
to
P, A plus P, B minus P, A intersect B.
Yep.
Got it? You need to get rid of one of them. Got it? So you could actually integrate from 1 to 4 straight away,
Same thing.
because that area you cannot count twice, you can count once. Yeah? If you draw it, you know that you can integrate from 1 to 4.
0 to
Yeah? If not, if you don't
0
draw
to
it, you got to integrate from 1 to 3, and then 2 to 4, and take away 2 to 3. Yeah? Because you need to know this. Probability of A union B is probability of A plus probability of B, take away probability of A intersect B. Yeah?
0.
You can do that.
6.
Or write it out like this. Or in fact, you know that it's straight away is 0 to 4. That's it.
Never back.
Agree? So it's actually technique of answering question. It's not that you have not learned this before.
The dream.
You have learned definite integral before. You have learned how to integrate with E. So therefore, you now just need to think what situation to do. Alright? So integrating from 1 to 4, that will give you 0 to 4, that is e to the power of minus 2 plus 1, or minus approximately 0.8467. So what I'm trying to do is expose you to as many different sort of questions as you can, so that you know when you're looking at the graph, you will be able to manipulate it. So the next bit, I want to look at x less than 7, which is from here onwards, right? However, you are told that it's between 5 and 10, all right? So 10 is here. So you need to find that area, integrate between 5 and 10, and then area between 5 and 7. All right? Again, integration. Last example here. So integration, same thing. This one, I just directly plug it into your class pad. Now, I'm going to show you a trick in terms of using class pad in this situation. All right? You know that fx, let's write it down so that I remember. Fx equals to 0.5 e to the power of minus 0.5x. All right, can you grab your class pad? Let's do it with me. Let's do it together with me.
No, I remember
All
what
right.
I was going to do.
So, to make
Just gonna
life a little bit easier for yourself.
You graph and then you use G-solve thing.
All right, if I go to main,
No, no.
let me clear everything first. All right? Here, I'm going to suggest to you,
Never give up.
if you've got integration that involves e and then 1 divided by the other, all right? Go to Maths 3 and define f x equals to 0.5 e to the power of minus 0.5x. Define it. All right? So it is done. Then, when you do your integration, all you need is integrate from 5 to 7 fx. You can just copy that down, x, and then 7, is it 7 to 10? I can't remember. 5 to 10, is that right? Sorry. Thank you. And then you've got your answer straight away. So you don't have to type in your function twice if you use the define. All right? But always in a new question, clear all the variables and clear all the numbers first, so that the calculator is not thinking that x is some other values. Right? So this is one way of doing it. Makes life just that bit little simpler for yourself if you use the define function. Alright, that's all I have for you today. Plenty of exercises for you to do. And we'll do a bit more next week.
You don't study.